Okay, welcome Stella. This is the exercise we're going to do. You asked me to do this question. But from here, I think it's already possible for you to easily do this question. You understand? It's a very simple question. From what we have already done, we know already how to find general solutions. You understand? And we know already how to find solutions when we are given a certain interval. You understand? So, but I will do it. It's a simple affair. Now, the first, the 2i, the 2 sub 2, they're asking us find the general solution of sine 4x plus cos 2x. Let me go. Uh, that's that's exercise. Wait, that's exercise 3, the June question. Okay. Let me go down. Let me go on a new paper. Let me first create other papers. 13, 14. Okay. We're on exercise. It's exercise 3. Yes. The June question. June question. Okay. The first the two sub 2 the 2 sub 2, yes, in the 2 sub 2 we have asked to, where is it even, we are asked to find the general solution of sine 4x plus cos 2x. Sine 4x plus cos 2x equals to 0. Yes, the general solution. Let me check again. Okay, here this simply means, look at something. I saw you were trying to write this, use double angle identities. That's wastage of time. Wastage of time. You see that with the techniques I just showed you, there's no need to waste time. There's no need to waste time. When you start developing that, you will end, you can spend your whole, in fact, a whole 1 hour. You will not even solve the question. When things are given like this, they're already simple like this. You just write it as this implies sine 4x will be equals to what? Minus cos 2x. Or it depends on you. You can bring the sine 4x to the other side. Is that okay? Now, when things are already like this, the question you have to ask yourself, you have your sine here. For you to use you have a mixture of sine and cos. For you to use the general solution of sine, it means that you have to turn this into a sine. Is that okay? If you instead write cos 2x being equals to minus sine 4x, is that okay? If you write it like this, it simply means that you are going, if you want to use a general solution of cos, it simply means that you are going to turn this this minus sine 4x into a cos. Is that okay? Now, I'll not use the 2 approach. I think I'll use this other one, because this one will be this one will be a very fast approach, if I will say it like this. This will be a very fast approach. Okay, this is what I'm going to do. Let me wipe this. Okay, let me wipe this. Now, this can be written as cos 2x being equals to minus sine 4x. Is that okay? Sine 4x. Yes. Okay. My aim here is what? My problem is I want to use the general solution of cos. You understand? My aim here is to use the general solution of cos. So I have to transform this into a cos. First of all, recall that sine of minus theta is equals to what? Minus sine theta. Is that okay? So this implies minus sine 4x will be equals to what? Sine will be equals to sine, oh wait, let me write this, will be equals to sine minus 4x. Is that okay? You can also use the trigonometric identity, which says that sine of what? Pi plus x is equals to what? Minus sine x. Is that okay? You can decide to use this, it depends on you, but me, I want to use this. So this implies our cos 2x will be equals to what? Sine of what? Minus 4x. The problem has not yet been resolved. We need to transform this into a cos in order to have cos y being equals to what? Cos a cos big Y being equals to a cos big X. Is that okay? Is that okay? For us to use the general solution of cos. Now, how do I turn this into a cos? Recall that sine of theta is equals to what? Cos of pi on 2 minus what? Is equals to cos of pi on 2 minus theta. Is that okay? Which is simply this, which is also the same as cos of 90 degrees minus theta. Is that okay? Okay, so this implies cos 2x will be equals to what? Will be equals to, I'll turn this into cos of what? Wait, let me first wipe this. Let me wipe this. So this implies sine minus 4x will be equals to what? Cos of pi on 2 minus 4x. Is that okay? This will be equals to cos of pi on 2 plus 4x. Is that okay? Very good. It implies then that where I will see sine 4 minus 4x, I will replace by cos of pi on 2 plus 4x. So cos 2x, this place, we are going to substitute it here. We are here. So cos 2x will be equals to what? Cos of pi on 2 plus 4x. Is that okay? Now we can already use the general solution of cos. So this implies, or it's implied by what? 2x being equals to what? Pi on 2 plus 4x plus 2k pi, or 2x, because this is our y, 2x being equals to what? Minus all this, minus pi on 2 plus 4x plus 2k pi, with k belonging to the set of integers. Okay, let's arrange things. So there's 4x here. Let's bring it on this side. So this implies, or it is implied by, our 2x minus 4x will be equals to pi on 2 plus 2k pi. Is that okay? Or this minus will attack this. When it comes like this, I'm going to have 2x plus 4x being equals to what? Being equals to minus pi on 2 plus 2k pi. Is that okay? With k belonging to the set of integers. Is that okay? Now, this implies, or it's implied by, this will give minus 2x being equals to pi on 2 plus 2k pi, or 6x being equals to what? Minus pi on 2 plus 2k pi, with k belonging to the set of integers. Is that okay? So now I will divide this one This implies, or it's implied by, I'll divide all through by what? 2. So this will give me x being equals to minus pi on 4. When I divide all through, I'll have minus k pi. Is that okay? Or x will be equals to what? I divide all through by 6. I'll have minus pi on the 12 plus k pi on the 3. Is that okay? Where k belongs to the set of integers. Okay, now I told you you can either leave it like this. You can either, at this level, you can either decide to work with this minus in front of this k, or you remove it. That will not affect anything. Because what? K is an integer. Do you understand what I'm saying? So be very careful. Take note of what I'm explaining, because they can decide to trick your brain during multiple choice questions. They can decide to trick your brain with this during multiple choice questions. They will give you the form where they will give you the general solutions where they'll put a plus here. When there is a minus here, you don't have the right to change. You only have the right to change it in front here. When it is plus, leave it as plus. But when it is minus in front of k here, you can change it into a plus, because the k is an integer. You understand what I'm saying? So be very careful. Be very, very careful. So this implies, or it's implied by, my x will be equals to minus pi on 4 plus k pi, or my x will be equals to what? Minus pi on 12 plus what? K pi on 3, where k belongs to z. So the general solution, the general solution S will be equals to what? Any number of this form or this form where k belongs to z. So we have minus pi on 4 plus k pi, comma, minus pi on the 12 plus k pi on 3, where k belongs to z. Let me drag it on the other side, where k belongs to a set of integers. That's your general solution. If I'm to write it in terms of degrees, this simply means that my general solution S will be equals to what? Pi on 5 is 45 degrees, so I will have minus 45 degrees plus k times 180 degrees. Is that okay? Or you put the k behind, plus 180 degree k, comma, let me wipe this. The other one, 180 degrees divided by 12. What is it? Let me calculate. 180 degrees divided by 12. 180 divided by 12. This gives 15 degrees. So since there is a minus here, this will be minus 15 degrees plus pi on 3 is simply 60 degrees. So I'll have 60 degrees k, where k belongs to the set of integers. So this is your general solution. Either you give it in terms of pi, or you give it in terms of, either you give it in terms of radians, or you give it in terms of degrees. So that's the general solution they were asking you to find. Very simple. Very, very simple. You see that things are very simple. So try to go through this exercise again and understand all what I did. You understand? Okay. The next question that you were being asked was, solve for x on this interval. Solve for x where x belongs to this interval, this equation. So they are asking you to find the solution of this equation on this interval. It's very simple. You first start by doing what? Finding the general solution. After finding the general solution, you find what? The values of k on this interval that will give you the values of k that will give you the solutions on this interval. And simple, you have everything. So let's proceed and do the things. We have to solve sine 3x plus cos x on the interval 0, 180 degrees. Okay, let me go to the solving. So the sub 3 part, the sub 3, we have to solve sine 3x plus cos x equals to 0 for x greater than or equals to 0 but less than or equals to 180 degrees. Very simple. Okay, the first thing we are supposed to do is step 1 is to find the general solution of sine 3x plus cos x. Very simple. Okay, in this question, okay, let's find the general solution. Okay, we have to solve sine 3x plus cos x being equals to 0. Okay, in this question, in the previous question, we brought the sine to this side. In this question, now let's try to work instead and bring what? The cos on this other side. You get what I'm saying? Okay, now sine this implies sine 3x will be equals to what? Minus cos x. Is that okay? Now the question you are to ask yourself, are you using the sine general solution or the cos general solution? Me, I will decide from what I put on my left side. When you see me putting already sine on the left side, understand that I'm going to use the sine general solution. You understand? So my aim here is to use the sine general solution. So I have to transform this into a sine. Is that okay? So I have to transform this into a sine. Is that okay? There are so many ways by which I can do this. First of all, yes, there are so many ways by which I can do this. I can first transform only cos to sine, knowing that the sine of an angle, of a negative angle, is equals to negative that angle. Is that okay? So that's even what I will do. Instead of using this formula, cos of pi plus x being equals to minus cos x. Instead of, you can still use it. You do that minus cos x is this. You understand? Yes, you can still decide to use this. Is the same thing. Okay, let me walk around with it. Okay, I'll first write this. Recall that cos theta is equals to sine of cos theta is equals to sine of pi on the 2 minus theta. Is that okay? That is sine of 90 degrees minus theta. So it implies minus cos x will be equals to what? Minus, I'll only apply this formula to this cos. So this will be minus sine of what? Pi on 2 minus theta. I did not transform all of this. This minus, I just copied it, and it is only this one that I transform using the formula sine. Oh, this is x, not theta. This is x. This is x. Is that okay? Is that okay? Now, having done it, this implies I'll then substitute where I see all of this by this. So this implies sine 3x will be equals to what? will be equals to minus sine of what? Pi on 2 minus x. Is that okay? But recall that the sine of minus theta is equals to minus sine theta. So this formula permits me to bring this minus inside. So this implies sine 3x will be equals to what? Will be equals to sine of what? Minus into what? Because the minus comes into pi on 2 minus x. Is that okay? Perfect. So this implies sine 3x will be equals to what? This becomes sine of what? X minus pi on 2. Is that okay? So we have already transformed what? From here, we have already transformed this from here to here. Is that okay? We have already transformed that from here to here. So at this stage, we can already use the general solution of sine capital Y equals to sine capital X. Is that okay? Where the capital Y will be this and the capital X will be what? This. So this implies, or it's implied by what? We know that from here, the general solution here, Y will be equals to what? X plus 2k pi, or Y will be equals to what? Pi minus X plus 2k pi. Is that okay? Where k belongs to the set of integers. That's the general solution for sine. So this implies or it's implied by 3x will be equals to x minus pi on 2 plus 2k pi, or or 3x will be equals to what? Or 3x will be equals to, we have to do pi minus this big X, pi minus x minus pi on 2 plus 2k pi, where k belongs to the set of integers. Is that okay? Okay, from there, this implies, or it's implied by, here I'll bring the x on this side. So this becomes 3x minus x being equals to what? Minus pi on 2 plus 2k pi, or this minus will attack this. When this x comes like this, it will make 4x. So I will have 3x plus x being equals to this pi. This will be equals to pi plus pi on 2 plus 2k pi, where k belongs to the set of integers. Is that okay? Okay, from there, this implies, or it's implied by, this will give 2x being equals to what? Minus pi on 2 plus 2k pi, or this 4x will be equals to this and this times this. This will give 3 pi on 2. Is that okay? 3 pi on 2. That will give 3 pi on 2. 3 pi on 2. 3 pi on 2 plus what? 3 pi on 2 plus 2k pi. Is that okay? Where k belongs to z. Okay, perfect. This implies, or it's implied by, this our x will be equals to, we divide all through by 2. So I'll have minus pi on 4 plus k pi, or x will be equals to what? When I divide by 4, I'll have 3 pi on 8 plus k pi on 2, where k belongs to the set of integers. So from here, it implies the general solution S will be any number of this form or this form where k belongs to what? A set of integers. So I'll have minus pi on 4 plus k pi, comma 3 pi on 8 plus k pi on 2 with k belonging to what? Z. So that's your general solution. Is that okay? If you are to give it in terms of degrees, since the interval was given in terms of degrees, S will be equals to what? The general solution, this is 45 degrees minus 45 degrees plus 180 degree K. Is that okay? Comma, here, I have 3 pi, wait, let me do 3 pi, that is 3 times 180 degrees divided by 8. 3 times 180, 3 times 180 divided by 8. That's 67.5. That's 67.5 degrees plus, this is pi divided by 2 is simply 90 degrees plus 90 degrees k, where k belongs to the set of integers. Okay, we have already our general solutions. Now we have to find step 2, finding the values of k's, finding the values of k that give solutions on the interval x greater than or equals to 0 but less than or equals to 180 degrees. Very good. Okay. We take the first one. We take this first one for x being equals to minus. This time I'm going to work with angles for you to have already also an idea how we go about with them. For x being equals to 45 degrees plus 180 degrees k. Okay, let's work with this first one. We have to recall that the exercise says that x is between 180 and between 0 and 180 degrees. Is 0 degrees. Recall that x is greater than or equals to 0 degrees but less than or equals to 180 degrees. This implies that what? This is our x. This is 45 degrees. We replace this our x here. So this implies minus 45 degrees plus 180 degrees k will be what? Greater than or equals to 0 degrees but less than or equals to what? 180 degrees. Is that okay? Now, our aim is to leave k alone here. So we have to first remove this 45. So we have to add 45 to each part of the inequality. So this implies 45 degrees. This will have minus 45 degrees. Let me put 0 degrees plus 45 plus 180 degrees k plus 45 degrees less than or equals to 180 degrees plus 45 degrees. Is that okay? Very good. So this implies this 45 will go with this 45. We will be left with 180 degrees k greater than or equals to 45 degrees less than or equals to what? Less than or equals to 45 plus this. This gives this is 225 degrees. Yes, 200, because 40 plus this is 220. So 225 degrees. Is that okay? Now we have to leave our k here. That means we have to divide all through by what? 180 degrees. So this implies I'll have here 45 all over 180 less than or equals to we have k here because this Well, divided by 180 degrees here, the 180 will go less than or equals to 225 divided by what? 180. Is that okay? I did not added the degrees because the degrees will cancel because this is degree. So this becomes a real number simply. You understand? Okay, now 45 divided by 90, was it? Let's calculate. 45 divided by 180, that's 0.25. This 0.25 k greater than or equals to this, but less than or equals to 225 divided by 180. 225 divided by 180. Let me punch it. That's 1.25. That's 1.25. Is that okay? So we see that if I'm to draw my inequality line, this is 0.25 and this is 1.25. This is closed. This is closed. So the numbers, the whole numbers that are interesting ourselves, that we are interested in, are the whole numbers that are found here. Okay, this is 0.25. It means that 0 is found here. The only whole integer that's found here is what? 1. That's the only integer found here. So this implies our k must be equals to 1. Is that okay? Now, when k is equals to 1, what do we have? When k is equals to 1, we substitute our 1 here. When k is equals to 1, x will be equals to minus 45 degrees plus 1 into plus 180 degrees times 1. Is that okay? So this will give, this implies x will be equals to 180 degrees minus 45 degrees. 180 degrees minus 45 degrees. I think that's 135 degrees. So x is equals to 135 degrees. So we find already. So S1 is equals to what? 135 degrees. Is that okay? The first solution set is 135 degrees. Is that okay? You can easily convert this 135 degrees into radian. You know how to convert into radian. So let's take the next one for x being equals to this for x being equals to this one. Okay. For so for x being equals to, this is 67.5 degrees plus 90 degree k. 67.5 degrees plus 90 degree k. Is that okay? Now, okay, recall that x must be equals to what? Between 0 degrees and 180 degrees. Is that okay? Let's try to do that. So this implies I'll take this and substitute here. I'll have 67.5 degrees plus 90 degree k greater than or equals to 0 but less than or equals to 180 degrees. Is that okay? Now, this implies I will remove this 67 here. So I'll subtract 67 from both parts. So I'll have 0 minus 67.5 degrees less than or equals to what? This 67.5 degrees plus 90 degree k minus 67.5 degree less than or equals to 180 degree minus 67.5 degree. Is that okay? Very good. Now I'll remove, so this and this will go. So this implies 90 degree k will be less than or equals to minus 67.5 degree less than or equals to what? Less than or equals to 180 degrees minus this. 180 degree. Wait, let me calculate that. 180 degrees minus 67.5 degrees. 180 minus 67.5. That's 112.5 degrees. 112 and 12, 112 and 12.5 degrees. Okay, very good. Now we have to divide all through by 90. So this implies I have 67.5 degrees divided by 90 by 90. Let me remove these degrees because there's no need of writing it. The degrees will cancel out. So less than or equals to, dividing, when we divide by 90, this becomes k, less than or equals to 112.5 divided by 90. Okay, 112 divided by 0.5 divided by 90. What was it? That's 1. That's 1. Don't forget that there is a minus here. Okay, that's 1.12. So k will be less than or equals to 1.25, greater than or equals to 67.5 divided by 90. Let me calculate it. 67.5 divided by 90. This gives 0.75. So I'll have minus 0.75. Is that okay? Let me check something. Okay, very good. Very good. Let me verify some things. Okay, it's very good. Okay, okay, this is now our k. When we draw it on the number line, I'm going to have here 0.75 minus 0.75. This is 1.25. Okay, it is close. So the integers must be found in this interval. Is that okay? So this is minus 0.75. It means that there is 0 inside here and there is what? 1. So we have to take 0 and 1. Perfect. So this implies our k has to take values 0 and 1. Okay, when k is equals to 0, what do we have? We come here, we substitute 0. When k is equals to 0, our x will be equals to, this is here, our x will be equals to 67.50 plus 90 degrees into 0. So this implies x will be equals to 67.5 degrees. Is that okay? When k equals to 1, our x will be equals to what? 67.5 degrees. 67.5 degrees plus 90 degrees into 1. Is that okay? So this implies our x will be equals to what? 90 degrees plus this 90 plus 60 is already 150. So this will be 157.5 degrees. You get what I'm saying? So our S2, the solutions will be 67.5 degrees and what? And 157.5 degrees. Is that okay? Now, the step 3, we are supposed to find the general solution. So, the solution on the interval 0, 180 degree of the equation, the solutions on this interval of the equations are S being equals to S1 union S2. Is that okay? So this will be equals to what? The first set was what? The first set was only 135 degrees. Is that okay? 135 degrees union the second set 67.5 degrees, comma 157.5 degrees. Is that okay? So this implies the general solution on this interval, pardon, the general solution on this interval will be, I take from the smallest, this is the smallest, this is 67. You can put it in any order, but you know that when we put answers in sets, we generally take from the smallest. This is 67.5 degrees, this is 135 degrees, and this is 157.5 degrees. When you look at these answers, you clearly see that they are in which interval? They are in this interval. So that's the exact way. You see exactly how we find values of k. We don't decide to take values of k anyhow. We don't decide to take values of k anyhow. That's how we find the exact values of k. So that was the solution to this exercise. See you in the next video. In the next video, let me see if there's still an exercise I have to do. Yes, in the next video, I'm going to let me see. In the next video, I'm going to solve this exercise. I'm going to solve this first one. Yes, I'll solve this first one, and you will have to solve these two other ones. Yes, you have to solve them. So in the next video, I'll only solve this. I'll only solve this. Yes, I'll only solve this. You have to solve this as assignment, this. Yes, because the B part. So I'll solve this first one because on the B part, they are saying deduce the solutions to this on this interval and on this interval. You understand? So I'll solve this A sub 1 and B, this I'll solve this A sub 1. Then I'll solve the B sub 1 and sub 2 for the A sub 1. You understand what I'm saying? So, and now you have to solve all the rest. You send me the solutions and I will check it. So you will also solve this question, this exercise 5. You have to solve this question, exercise 5, and you will also try to solve this question. You understand? You also try to solve this question. So in the next video, I'll only solve A sub 1 and B sub 1 and sub 2 for question this, because here they are saying deduce the solutions to the above equations. The above equations are this. You understand what I'm saying? Okay. So see you in the next video.